Well, I would like to put these four integrals for a comparison, to compare these four integrals. And I've done these two on another video, and you can go see it. The link is below. These two are relatively easier. Now today I want to do these two integrals. Now these are a little complicated, and each one of them I use two methods. So it's today could be a little longer. Okay, let me do this one first. Two methods. Method one. Method one, I start this. Multiply by numerator, denominator, both by sine x. So this is sine x dx. This will be sine square x. And 2, this is 2 cosine square x minus 1. Now and then I have an idea that I change everything into cosine. So the numerator becomes d cosine. Cosine derivative is a negative sign, so it's a negative outside. This will be cosine. This will be, this has been already cosine. So 2 cosine square minus 1. Now it's ready for changing. Right? I'll let u be cosine. So integral has been changed into negative du 1 minus u square and the square root 2u square minus 1. Wow. Yeah, next step is crucial and also strange that I'm doing this way. Integral du, the denominator, I multiply this and divide this again. So in other words, I multiply by 2u square on denominator. Same time multiply this one on top. So it becomes 2u square minus 1, 3/2. Right? That is equal, right? Both times this one, numerator, denominator. Now and then something happened. Well, first this one. Let me discuss this one. 1 minus u square over 2u square minus 1. This one is equal to u square minus 2u square minus 1, right? 2u square minus 1. So this begin changing into u over this square minus 1, yeah. So I want to change this one into this. That is one idea, changing this one. Now the other idea is this. The derivative of u over square root 2u square minus 1. That derivative with respect to u, the use quotient rule, this will be 2u square minus 1. And numerator will becomes this derivative times this one, which is this, 2u square minus 1, minus u times this one derivative. This one derivative with respect to u is, right, 1 over that, multiply the derivative of the inside, that's a chain rule, is 4u times du. Then this becomes, if I multiply by this, both top and the bottom becomes 2u squared minus 1, 3 halves. This will be 2u minus square, 2u squared minus 1. And this will cancel out. It becomes a 2u squared, right, du. And after simplification, is equal to negative u squared, no, negative 1, negative du, sorry, and 2u squared minus 1, 3 halves. Wow. This is this. Okay? So what I've worked at, this is this. This is that. So my integral changed. Well, this becomes this, right? Becomes u square root 2u square minus 1 square minus 1. Right? This is this. This is this. And that is a negative this. Negative is equal to this. So I do have negative. To cancel negative, it becomes a d u over 2u square minus 1. Okay. So this one is equal to negative that. That will work out. Then, well, we have a formula, integral d something over something squared minus 1, right? If I'm not using hyperbolic tangent, that is this, 1/2 natural log something minus 1 over something plus 1. But if you don't know this formula, you can do it by partial fractions. You can get this. Right? So this is equal to half natural log this minus 1 square root 2u square minus 1 minus 1 u over 2u square minus 1 plus 1 plus c. So the integral has been done. It's just a matter of simplification and put back x. Yeah, okay, to simplify this one, multiply by this one, both top and the bottom, becomes u minus square 2u square, right? U plus, no, minus, sorry, plus c, okay? Yeah. Then natural log. How to simplify this one? I multiply by this one, top and the bottom again. So this one, this is equal to this square, right? I multiply this one. I time this one numerator denominator. So denominator becomes u square minus 2u square minus 1. So this one equal to 1/2 log, well, this is u minus the square root 2u square minus 1 square This would be 1 minus u squared. Yeah. Well, this half is a square root. Square root, right? If I change the square root, it becomes a log 1 u minus square root 2 u squared minus 1 plus c. This is square root, right? 1 minus u squared square root. And what is u? U is cosine. So it becomes a natural log. This is cosine. Cosine squared becomes cosine, right? No, this is square. 1 minus cosine squared is sine. Ah, I'm sorry. This is cosine minus 2 cosine square minus 1. Yeah, plus c. It's better. Now then, cosine over sine is cotangent. This one goes to square root, becomes square, right? This is sine squared. It becomes 2 cotangent square. 1 over sine square is cosecant square. Wow. Then this is cotangent. Finally, I get nice answer. This minus this one is a cotangent square max minus 1. Well, that is a final answer for this integral by method 1. I told you this integral is not that easy to do. Well, anyhow, I've done it by method 1. Now, then method 2. Method 2, this is dx, this is sine x cosine 2x. Method 2. Well, method 2 is this. I change the denominator into sine. Sine x is 1 minus 2 sine square x. Well, you must be good in trigonometry. This is why integration is not easy, because when you study the integrations, you need everything you have learned before: arithmetics, algebra, trigonometry, functions, and derivative, chain root, whatever, and it must be very good. Then you can do integrations nicely. Now here, I take sine out of the square root. This is dx. I take sine out, which means I take sine square out. So it becomes sine square. Take sine square out is a 1 over sine square. That is this one. And minus 2. Yeah. So this one is equal to, this one goes on top is a cosecant square dx. This would be what? This would be cosecant square minus 2. Yeah. And we further simplify. cosecant square x dx is a negative d cotangent, negative outside. This one minus 2 is cotangent square minus 1, right? Then to get rid of a square root, we're using trigonometric. Let the cotangent x be secant theta, right? Yeah. So this becomes negative. This is negative. D cotangent would be d secant theta. This will be secant square minus 1, right? Secant square minus 1. And this is equal to negative. This is a secant 10. Secant square minus 1 is tangent square, right? And this is cancel out, equal to negative secant. Secant. Okay, so this is equal to negative. Secant integral is log secant plus 10. Well, I suppose you have done this before, or you can easily do this one by using by parts, something like that. Then we change it into this one. Secant theta is what? Secant theta is cotangent. And tangent is what? Tangent theta is a secant square minus 1, right? Secant square minus 1. Secant square is this, so it can become this. Minus 1, yeah. Yeah, plus C. Well, compared to method of 1, this is method of 1. This is method of 2. Now let me verify they are the same. So this is actually equal to 1 over cotangent x plus the square root cotangent square x minus 1, right? Because negative becomes here, the reciprocal. So then I multiply by this one top and the bottom. Yeah, multiply by cotangent x minus this. I time this one, both top and the bottom. So top will become this. The bottom becomes cotangent square minus this is square, right? Cotangent square x minus 1. So this one is equal to natural log. The bottom will become 1. So it becomes a cotangent x minus square root cotangent square x minus 1. Wow, this is the same answer as we have done in method 1. Okay, so good. We've done this one by 2 methods. What what a work. Now we come to this one by two methods. Well, as I told you, this integral is not easy. Okay, so how we how do we start? Uh, Method one. I multiply by numerator, denominator both by cosine. So this is cosine x dx. This will be cosine square x, and change everything into, or change this one into sine, which is 1 minus 2 sine square x. And here the idea is that I want to change everything to sine. So change to sine, this is d sine x, right? This will be 1 minus sine square. This has been already in sine, 1 minus 2 sine square. Well, here, instead of using the substitution U method, let me try the other way. Try use something else. I want to get rid of a square root, so I let 2 sine x squared x be sine squared theta. So I can get rid of square root, right? So if this is so, then sine x is equal to 1 over square root 2 sine theta. Then I take d sine will be d sine x will be equal to 1 over square root 2 cosine theta d theta, right? Yeah, so integral has been changed into, the numerator is 1 over root 2 cosine theta d theta. Yeah, sine theta is this, right? Is 1 half. So 1 minus 1 half sine square theta. Yeah, that is this one. This has been changed. 1 minus, this is 1 minus sine square theta. Yeah, very good. So this is cosine. Cosine, this cancel out, right? It becomes a 1 over root 2. This is d theta. This is 1 minus half sine square theta. Yeah, this will equal to, well, multiply by 2, both top and the bottom, times 2 on top, times 2 on bottom. This is 2 minus sine square theta, right? Here it becomes root 2. This is root 2 integral d theta. This is 1 plus cosine square theta. Yeah, that's correct, isn't it? Well, what then? Let me change. Let me delete the sign. Cosine square. This is root 2 integral d theta 1 plus half 1 plus cosine 2 theta. And then multiply by 2 again. This is 2 root 2 integral d theta 3 plus cosine 2 theta. Well, then for the convenience of calculation, I'll put d theta into 2 d theta. This is equal to, I change it to d theta to 2 d theta, right? So this 2 is gone. 2 d theta is this. Right? This is 3 plus cosine 2 theta. And then my variable is 2 theta. Then I can use Weierstrass substitution, right? This is equal to, well, if this is theta, I'll let theta be arctangent half theta, right? But this is 2 theta, so t is equal to tangent theta instead. Actually, 2 theta is half theta. Then this is 2, and dx will be equal to what? Will be equal to 2, 1 plus t squared dt. This is 3 plus 1 minus t squared, 1 plus t squared. That is a famous substitution method. Instead of a half theta, because 2 theta, therefore it's tangent theta. So this one is equal to square root 2 root 2. Is 2 root 2. This is cancel out. Becomes dt and 4 minus 2t squared. Okay? Multiply by 1 plus t squared, both top and the bottom. And then I take a 2 out, right? Becomes root 2. This is a dt. This is 2 plus t squared. Now we have a formula, right? Arctangent formula. So this will equal to root 2 times 1 over root 2 arctangent t over root 2, right? Plus c. Yeah. And we put t back. Put a t back. Yeah. What's t? T is tangent theta. So this is arctangent. Tangent theta over root 2 plus c. And this is equal to arctangent 1 over root 2. Tangent is sine over cosine. Sine is this, right? Sine is root 2 something. Sine theta is root 2 sine x. Root 2 sine x. Right? Cosine is this. Is 1 minus 2 sine square x. See? Cosine is 1 minus sine square. 1 minus this is, yeah. Then root 2 cancel out. It's arctangent. This is root cosine root 2x. This is sine x. Well, finally, we get this is the answer for this integral by method 1. Well, it's quite some integral. Now, method 2. Method 2, well, cosine x square root cosine 2x. Well, this is not a very easy integral. Well, I multiply by cosine both top and the bottom. We're going to cosine x dx. This becomes a cosine square. This becomes a 1 minus 2 sine square x. The idea is to change everything into sine. Everything into sine, right? This is equal to, this is d sine. Now change to sine. This is 1 minus sine square. This has been already in sine. Okay, then it's ready for substitution, right? Let the u be sine x. So this becomes du 1 minus u square and 1 minus 2u square root, right? 1/2. I change. Yeah. Excuse me, I don't have a pen. Let me get it. Okay, let me get a pen. All right. Well, how come the pen doesn't work? Let me use this pen. This is 1/2, right? 2u square. Yeah. Okay. And I divide by this 1 minus 2u. Then this one at time, this same thing. It becomes 1 minus 2u square 3/2. Okay. And you get a piece of paper. Now, same thing as done the other integral. This is 1 minus u square, 1 minus 2u square is equal to 1 plus 2u square plus u square, right? This is 1 plus 2u square. So it becomes a 1 plus u square over 1 minus 2u square. Wow. Right? So I can change this one into 1 plus u over 1 square root 1 plus minus 2u square. Yeah. So this one is equal to this. It's better. Okay. For that one, same thing for the derivative u over 1 minus 2u square. This one derivative with respect to u. This is equal to quotient rule 1 minus u square. Huh? And the numerator becomes this derivative time. This one is this minus this time this derivative, which is 1 times this one, is 2 over 1 minus u square times negative 4u d. Yeah. Then this one is equal to multiply this one, both top and the bottom, becomes 1 minus 2u square 3 halves. So it becomes a 1 minus this 2 cancel out as 2u. 2u is negative plus 2u square. Right, this is a cancel out. So to end up with 1 minus 2u square. On top it would be u square. Du. No, 2u square cancel out. I'm sorry, this is equal to 1. All right, so this one is equal to this. So in other words, this one is equal to this. And that one is equal to this. So it becomes integral. This is 1 plus u over this minus 2u square, right? This is this. So this one is this. And that one is this. So it becomes a d u over 1 minus 2u square. Yeah. That is easier because we have a formula, right? D something, 1 plus something square is equal to arctangent something, right? That's the basic formula. So this is equal to arctangent u over 1 minus 2u square plus c. Then we put back x, this is arctangent. Sine x is u, and 1 minus 2 sine x. That is simply cosine 2x, right? So this is equal to arctangent square root cosine 2x. Wow, that is the same thing as I've done it. Where is it? I couldn't find it. Well, I'm sorry I couldn't find it. But anyhow, this is the same answer as I've done in the same method, the first method for here. that is what I've done in the first method. Now this is done the second method. Well, so I've done this integral by two methods, and The other video, you can go see it. The link is below that. I've done the other two. So together I have four integrals, and they're very, very nice to have a comparison. I hope you like it, Thank you.